What's up, guys? So sorry to be wearing a tank top, it's super hot here in Brazil. I had to turn off the fan because I don't want the noise to be all weird. So I don't know how long this is gonna take me, but we're gonna do the entire C track on Solo Learn. Solo Learn for me is the best way for you to get started with any programming language you wanna know. They give a great foundation. I think they're better than Code Academy, all those resources. So let's learn C right now. It's gonna take a long time, but it's gonna be fun. And C is beautiful. C is beautiful. So I hope you guys enjoyed this video. I hope you guys enjoyed this tutorial. Let me check if the battery of my audio is good, because I don't wanna talk for 3 hours and then realize the audio was not working. So we're gonna test things out in the CS50 sandbox. So you can Google CS50 sandbox and it's gonna show you the first link. So this is a place for you to like play around with C. And let's do it. Let's start. So what is C? C is what you learn after you sign in. So let me sign in. You guys can email me at rodrigomlp@doorscodingschool.com. Password is secret, guys. I won't tell you. All right, so sign in now. I'm signing. So let's get started with C. Okay, let's do it. So what is C? Let me zoom in so you guys can see. Is a general programming language that has been around for nearly 50 years. It's really old. A lot of the first operating systems were written in C. It's really low level, but it really allows you to understand how your computer works, how memory works. So we'll see all that, pointers, all this thing in this tutorial. So quiz with me. So what is C? Photo editing, general purpose, client side. So it's a general purpose programming language. I want to see if I'll have this energy by the end of the video because it's gonna be long, but let's do it. So this is the first programming language first snippet of code we're gonna try out. So it's our hello world. So let me sign in with my GitHub account here on CS50 sandbox. You don't need to do that. Actually, we can just try the code here on Solo Learn. So why do we need CS50? So we can just click run. So what is this all about? So if you've never coded before, this is basically saying, hey, whatever you put inside of the print is gonna show up here on the right screen called terminal. So usually when we're coding, you have the black screen you see on movies called terminal. So almost all programming environments you're gonna see on the CS50 sandbox has this screen, and that's where you can see the results of your code. Main is like how you start your program. So whatever is inside of main, we're gonna learn more how it works, but basically it's okay, when you start your program, the first thing that gets started is whatever is inside of main. Return 0 means that you did whatever you had to do and you're successful. And include stdio.h allows us to use this function, printf. So printf is a function. It's like a button in a remote control, but we only have access to that if we include the code that someone else wrote, because it doesn't come out of nowhere, but someone has to write that for us. So if I remove this, you guys will see that it's gonna complain. It's gonna say, hey, printf, we don't know what printf is. So here it's saying like, printf, what's printf? You should include this. So basically, in order for you to be able to use printf, you need to put this. It allows us to use a bunch of functions, mechanisms for us through this code, okay? So don't forget to use the semicolon after every line. That's really important in C. You get an error if you don't do, so watch out for that. Some programming languages don't require that, curly braces, so on and so forth. So I recommend you guys to do this here on the sandbox. So what you can do is you can create a new file called start no, I don't know, programming.c. So any file, so this is free, guys. You just Google Cs50 sandbox, you log in, and you can do what I'm doing. You create a file, so you need to include the library. So in order for you to be able to stdio.h, that allows you to use printf. So you can say hello world. And then don't forget the semicolon, return 0 to say it was successful. And that is all wrapped around a function called main. What's this int thing? We're gonna see later. So let's just make sure we run this. Control X, Control V. What's my Control V? Anyway. Hello world, return 0. So what you're gonna do here on the terminal, how do you run this code? So that was like a fake thing. You just click on a button, but that doesn't exist in the real world. In the real world, you need to turn this into ones and zeros because that's the language that computers understand. The way you're gonna do this is to write make and the name of the file, programming.c. You press enter. Oh, you don't have the .c, just programming. And that's gonna turn that into ones and zeros. So it's complaining, so I already did something wrong. So blah blah blah, int printf, what is it saying? I forgot the printf. Where's the F, Rodrigo? Now it's gonna work. I don't wanna open this. Okay? So make programming, now it's gonna work. To run, it's / the name of the program, programming. So now you can see hello world. It didn't go, observe the cursor is in the same line as what was outputted here. I don't want that. So what I can do is to put a \n. So that means I will go to the next line. Every time you change something in your code, you wanna turn that into ones and zeros again. And then you run the code. So then you say programming, hello world, okay? So that's our first program in C, pretty basic, so let's continue. So what do you include at the top? stdio.h, so that's what allows us to use the printf. Let me see if everything's working with my audio, hopefully it is, okay? Let's continue. So hello world, so basically he's saying that printf is the one responsible for displaying on the terminal on the black screen. This is the terminal. And how do you print stuff? We say printf. I like this because it repeats itself over and over again. That's the best way to learn, repetition. You gotta repeat the same concepts over and over again. Don't forget the semicolon at the end, okay? So I think we did well here. I think we passed. So now data types. So this was what the int, where the int comes from. Every data in C, you need to tell what kind of data you're dealing with. Is that an integer? Is that a string? Is that a double? Is that a char? String doesn't exist in C. You don't need to know what that is now. But an int is an integer. So you gotta say, hey, here's an int. Here's a decimal point. So that's called a float or a double. Both things are decimal points. Double is more precise than a float. It's a character, so we're gonna call it char. So that's how we declare variables. So variables is the idea of storing things. Let's first see this right now. So let's run this. So it's basically saying, hey, an int occupies 4 spots in your memory. A float 8, a double 4, a double 8. So what does 8 mean? It means that double is more precise than float because it requires more memory, so you can store more decimal points. Don't worry too much about that now, that's not too important. Just think, hey, if it's an integer, I'll say int. If it's a decimal, float. If it's a character, char. Don't worry too much about the size and those things. So what are the data types in C? So that's int, float, string doesn't exist, int, float, double char, those are the data types. So string and boolean exist in other programming languages, not in C. So what are variables? I mentioned variables. So variables are it's an area of memory. So let's say you want to store a number somewhere. You create a variable. So for example, 42, I'm going to store in my R. So now every time you use this name, my var, it's going to be replaced by 42. So let's see that working. So I'm declaring, this is called declaring a variable. Say, hey, I'm gonna create two variables. Usually we use letters or a bunch of letters to represent something. So hey, I'm gonna create two integers. I'm gonna create a decimal point called salary. That salary value is 53.23. And I have a letter. So the type of a letter is char, whose value is z. Then I declare a equals 8. So from now on, every time I reference a, you can think of it as an 8. I can change it later, but that's the rule. B is going to be 34. Now C is a plus b. What's a? 8. What's b? 34. So now my C will be equal to 42. So from now on, C, every time I talk about C, it's 42. Then I print 42, which is the value of. So when you wanna print variables, you need to use this weird notation. So you first do a percent, then you put a letter, and then comma the variable. What that means is %d is for integers, %f is for float, %c for letters. So what is this saying is print an integer whose value is c, in this case 42. Print a decimal point whose value is salary. Print a character, so a letter, whose value is letter. So that should print C is 42, we did the math, salary is 56.23, and letter is Z. Okay, awesome, so that's exactly what we got. Alright, so let's move on. So that's the idea of variable. So he wants me to declare a variable called int and assign the value of 42 to that. So let's do that. A constant is a value that doesn't change. So for example, pi, do you want to change the value of pi? Or gravity, do you want to change the value of gravity? No, because those are things that remain constant. So you use this word called const. And what is interesting about const is that I can't change it. So since I have to pay to use this functionality, let's put here const. So const double pi 3.4. Okay. So now I'm gonna print that. I'm gonna print the constant. So remember, if I wanna print a float, I do %f pi, and this is around. Okay, so %n. Let's go. So remember, make the name of the program. So that turns my program into ones and zeros. And now I run. So programming. So 3.14, which is the value of my constant. I hope you guys can see. Let me zoom in. Okay. Oops, I zoom in too much. Let me show you guys. Let me make this smaller. Okay. Okay. So what if I want to change double pi to something else? So from now on, pi will be 3.15. When I compile this, it's gonna complain. It's gonna say, hey, this is a constant. You can't change that. So this is good because it makes your code safe. Once you declare that as a constant, you can't change it anymore. So how do you make a variable constant? You say const double pi. All right. So we're making progress here. Let's see how far we've gone. So we are almost there. We just have all of this. So we're gonna have fun. It's gonna take some time. Choose 16. Let's see how far. So C supports a number. So we need to get the user input. Let's say I wanna ask you, like, what's your age? How old are you? I need to have a way of asking. So you have this get char. Remember, you could use printf. We can use get char. So it's like a function. That's called a function. So a function is something that has a name, in this case get char, and parentheses. So what's inside of the parentheses is the value you wanna input, and then you get an output. So for example, char a equals get char, and then that's gonna store, so what's that doing is that's gonna store a character in this variable, and then you're gonna print it. So let's see. So we say char a equals get char, and then you printf that char. So you guys will see what this will look like. So again, make programming. Oops, I forgot a semicolon. You see, it's a very common mistake because I use Python a lot. So make programming. So when I run this programming, it's gonna first ask me for an input. So I'll say for a letter, I'll type in R, enter, and it's gonna return me R. So pretty simple. I type something and it returns an output what I printed. So pretty straightforward stuff. What else? I have a gets function. So a get chart gets a letter, but most things we ask from users is not a letter. It's actually a bunch of letters. So you can use gets, but we use something called an array that we'll see pretty soon. So I don't want to touch on that right now. So let's wait a little bit to talk about this one. And scanf is for numbers. So I can ask a user for a number. So in C it's kind of weird because other programming language is much easier. But I can say int a, and then I say scanf %a a. Is that how it's done? Let's see. %d a. Oh, I did %. Yes, and then I print a. I print a. So let's see how that works. I'm gonna run. It's gonna ask me for a number 5, and it's gonna print 5. So if it's a number, I use scanf. If it's a letter, I use get char. If it's a sequence of letters, I use gets. I don't want to talk about this right now. It's called an array. We'll talk about that later. But if I want to get a char, I use get char. If I want to ask the user for like yes or no, type y or n. Use get char. So output, he will talk about put char. So for example, if I want to print a character, I can use put char. If I want to print a bunch of letters, I can use puts. And the most common way is using printf. So I don't know why he's talking about this, but let's move on. So if you wanna print, I would say printf %c, not put char, but it's good to know it exists. So I can format my input a certain way. So for example, I can first print my integer, then float, then a string, and then I can, for example, you have all ways of formatting stuff. So for example, so this is like, I don't want, as I'm doing this problem, I don't want you guys, I'm gonna tell you what to focus on or not when you are doing this for learning. For example, this is not so important. I don't even memorize this. This is like, okay, how many decimal points do you want? How many do you want to ignore? So, for example, fill in the blanks to input two integer variables using scanf. So, num1 is an integer, so fill in the blanks. Okay, so this will be scanf. What's that? Fill in the blanks to input two integer variables using scanf. So let's see how that's done. Okay, so that will be percent. Oh yeah, so percent ampersand num1 ampersand num2. So basically this is asking, so scanf we saw how it works. So you get, so basically is how you ask the user for two integers. You say the two, so this percent d means, hey, I want two integers. Then you put the variables you want to store those inputs on, and you use the ampersand sign to basically go to that address. We're gonna talk more about ampersand when we talk about pointers, but for now just think of this as hey, I'm gonna store the value of num1 in this variable. Okay, so don't worry about too much this formatting thing. Again, so it's just talking about like backslash n is important, so we talk about that. If you wanna go to the next line, if you want a tab, so a space, a bunch of spaces, you can use that. So you can always Google this kind of thing. This is not so important. So fill in the blanks to print 442. So basically he wants only the the two first decimals. So this is defined by what comes after this dot. So that's basically dot to f means, hey, grab this value and I only care about the first two decimal points. But not too important, guys, so don't worry too much about that. What I spoke previously, this is really important. So how do you comment? Comment is basically if you wanna like not to run your code, but say something, hey, I'm asking user for a integer. So that is really helpful because it explains to someone else reading your code what that is about. Okay, so backslash, that's how you put a comment. So for multiple lines, you do backslash star backslash to close. So that will make these 3 lines into comments, 1, 2, 3. Okay. For 1 line comment, you do 2 forward slash, like I said, so 2 forward slashes. So that's great. So this is pretty the beginning of C. So let's see how far we've gone. Okay, so we're almost done with this first basic concepts. Then things get more fun because then it's more like useful things we can do. We go all the way to memory management. So stand with me, let's go, don't give up. 225. So we can do plus, division. The more interesting is module. So module is basically, so I can do like int a, so I can say something like a, let me make this smaller, a equals 2 plus 3, right? So a now will be 5, and then I can print what the value of a is, so that will be 5. Okay, so if I compile and run this should give me 5. Let me change because we just print 5, so 6. This will give me 8. Let me save, let me compile. So this is called compiling, turning my code into ones and zeros. Let me compile. There was an error because I forgot the semicolon. Again, don't forget the semicolon. Let's compile. Let's run. programming, boom, 8. So this is arithmetic operations. The more interesting one in C is the module. So module is very interesting because this is an operation we don't see in math. So programming. So that's true. Why should? So module gives you the result of the rest of a division. So 8 divided by 3, the quotient will be 2, so that's 2 times 3 times 2 is 6. To get to 8, I need to add 2, so that's the rest of my division. So that's what my module will give. This is very useful because for any number that is even, when I do the module by 2, that gives me 0, so I can check if a number is even or odd. For example, 8 module 2 is 0, because the rest of a division of 8 by 2 is 0. So, so then that's equal 0. So I can have a check of even or odd numbers. For example, I can say something like, I can check if a number is even or odd. Okay, let me delete this. Let me make this bigger. So I can say like A equals 18. So if A module 2 equals 0, printf D, because it's an integer, A. So I'll print the number, and I can say something, the number, and this will be the value, is even. The number 18 is even. So let's compile. Oops, what did I forget? I forgot to close the main function. Let me zoom out because it's, yes, so this is better. Okay, so now I'm gonna compile without errors, make programming. What's missing? The semicolon again. Python, you stay with me. And now if I run, it's gonna say that the number 18 is even because I use module. All right. So here he's talking about module because it's an integer. So what's 12 divided by 5? Without the decimal point, just like an integer division. The quotient will be 2 and the rest will be 2, so that's equal to. Okay, so another important thing is precedence. So what happens before the other? So if you do minus, plus, what comes before the other? So this is very similar to math, where the negative sign plus have the same precedence. So you first take the minus, then you do the plus. Multiplication and division have higher precedence than plus or minus. And you can have parentheses to enforce certain rules. So I can say, hey, first do A plus 2, then divide the result by C. So very similar to math. So fill in the blanks to subtract y from x. So and add z to the result. So that's pretty straightforward. You can do math in programming. We can convert a float to an integer, so we can convert, for example, price is a decimal point, int is an integer. When you sum a float with an integer, you get a float, so new price will be 8.5, and then you can print the value, so the output new price will be 8.5. okay, and we can cast. So cast is, you can turn a value into a float. So 23 divided by, so let's say A is 23, B is 5. If I do, let's say C will be 23 divided by 5, okay? And then I print then I'm gonna print, let's go, I'm gonna print C. So what do you guys think C will be? What do you guys think C will be? C will be a very interesting value. So let's see, let's compile. So make, again, that's a compilation, turn that into ones and zeros. And now I run the program saying ./. So that's 4. So when you divide two integers, it gets rid of the decimal points. If I want to turn this into a regular division, I need to put a float. So I'll turn this into a decimal point, and then I'll get the dot something, like 4 point something. So that's called casting. Okay, so why didn't it work? Because the %d sign means it's an integer, but actually, and also I'm saying that C is a int. I need to turn my variable C into a float. So now that will give me the right value. So programming 4.002. I can do that 0.2 thing that I was telling you guys because I just want 2 decimal points. So I can say make programming to run. So that will give me 4.260. So when you want to define how many decimal points you want, you can put point something. Okay, so I want to cast 2 integers, so to a float, so I can get decimal points. I say float. Let me see the time. Let me see if the battery is good. We're good. Let's keep going. We're doing good. So assignment operators, that's the equal sign. So we have interesting things. We have minus, equals, blah, 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 blah. Let's see how that works. So if I want to add 1 to B, I can say something like B equals B plus 1. But there is a shorter version. I can say, so B equals B plus 1 is the same. So now I comment that out, is the same as this. So B plus equals 1 is the same as B equals B plus 1. So what's B equals B plus 1? Programming is weird because first we do what's on the right hand side and then we assign it to B. So what's the value of B? 5 plus 1, 6. Now we assign that to B. That's 6. That's 6. Or I can do this shorthand version, which is much more common in programming. So the most common one is B plus equals. But you can also have minus equals, so that would be equals B minus 1. You can have times equals 1. So it's a shorter version of those other operations. So typing the missing operator to, oh yeah, and if I want to add a value to it's, so let's say I want to add B with A. B equals B plus A. Instead of doing this, I can say plus equals A. So that's the same as saying B equals B plus A, adding A to B. So that's what he wants here, to add num2 to num1 and reassigning to num1. Or we can do plus plus. So another version of doing B equals, so there are 3 ways of doing the same thing. And they are pretty common, so it's good to memorize this. So in the 3 scenarios here, I'm adding 1 to B. So you can pick whatever you feel more comfortable, okay? So let's do it. So what is the value of X after the following code? I love these problems because they make you think. So X will be 9 after this because the plus plus adds 1 to 8. And now I'm adding Y to X. So what's the value of Y? 7. After this line, this was 9. So 7 plus 9, 16. Observe it has a minus minus, but this minus will only have effect after I assign it to X. So then Y will become 6 but I've already added 2x, so that's not gonna be, it's not gonna be 9 plus 6, it's 9 plus 7. So let's see, that's it. I'm still sharp on my C, but it's not C sharp. So what is the starting point of so how do you start a C program? The compiler, which is that program that starts your program, always looks for the main function. So this is the final of chapter quiz, so it's a good review. So how do I say I love C? I can say printf C, and then don't forget the semicolon. Semicolon, okay? Single line comment, 2 forward slashes, declare a variable and add called sum, so a variable called sum, and you will have the addition of A plus B. Where's my plus sign? Plus sign. All right. So how to include, I do, so printf means I have access to a bunch of functions. One of them is printf. We saw also get char, put char, but the most important is printf, scanf. It all comes with this line, stdio, so it allows us to use these functions. So I use hashtag include stdio. Now if I want to print v, I say printf %d, meaning %d is an integer, and then I say v. Okay? Awesome. So we're done with this first module. So if you want to take a break now, take a deep breath. We will continue with a very special topic. We're looking into conditionals and loops. So this is like common to all programming languages. If you're learning C, this will be useful in all programming languages. So we'll learn about conditionals and loops, functions, arrays, and pointers, and then we keep on going. So let's do it. So conditionals. So this is like, if something happens, I'll do something, else I'll do something else. For example, score is 89. If the score is greater than 75, I say you passed. So for example, A equals B. I can say something like, if A is greater than 20, you put these curly braces and you can say, hey, you are awesome. 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 Not so awesome because it's taking me some time to do this, okay? Else, so if this condition is true, print you're awesome. Else, printf you're not so awesome. You're okay. You are okay. Okay? Okay. So now let's make programming and let's see what's going on. Printf, yes, we need to remove this line. Let me zoom out so you guys can see the whole code. So basically what we have is a value of A. If A is greater than 20, print you're awesome. Otherwise, print okay. So what do you think is gonna get printed on my terminal? Think about it while I type. I have this new keyboard and I'm still figuring out. Okay, so you're awesome. Why? Because I am awesome. No, it's because A is 23 and we're checking if A is greater than 20. So if else, really important. So how do I print hello to the screen? I can say if A is greater than B, print hello. And then I have all these signs I can use. I have less, less or equal, greater, greater equals, equals equals, different. So I can do all that. So this is a good example. So it involves what we learned. So int A equals 23. If I say A plus equals 1, what will be the value of A? 24. So I can say something. If A is 24, if I want to compare a variable with a value, I use two equals, equals, equals. Okay? So then I say, if that's equal to 24, print you are awesome, else you're okay. So is it gonna print you're awesome again or you're okay? Let's see. So now let's run. Run. No. So / programming. You are awesome. If I change this to 23, it would say you're okay because I'm adding 1 to 23. You're okay. Don't forget the \n because it makes our lives easier. \n. Compile. Compilation is important. You're okay. Okay? So that's it. So equality, plus or equal. So play around with this. So what is the correct for operator? Equals, right? So if you want to check if a variable is equal to other, you say equals. This is talking about if and else. I already showed you guys. So for example, if people, what does he want us to do? Fill in the blanks more than to 10 if the people variable is greater than 10. So if people is greater than 10, people is 12. So if people is greater than 10, it's gonna print more than 10, which is what's gonna get printed. Otherwise, print less than 10. So else, print less than 10. Oops, what did I do wrong? Let me go back. Let's continue. So he wants us to print less than 10. So this condition here on the top has to be false. If it's true, it's gonna print more than 10, but he wants us to print less than 10. So that means we make a less sign. So this is false. And then, wait. Less or equal. So that's why. Less or equal, else. If I make a mistake right now, okay, I need to read more carefully. So fill in the blanks more than 10 if the people variable is greater or equal to 10. Greater or equal. Print, oh, that's why I made a mistake. Okay, I don't know. That's why, guys, read the problem carefully. Don't do like myself. Okay, so conditionals. So he's talking about if and else. So a short version of doing an if and else is doing this question, in this line here. So basically he's saying if x is greater or equal than 5, let me zoom in so you guys can see. If x is greater or equal than 5, 5, otherwise x. So this is a way I don't like, but you can see some problem somewhere. It's a way for you to say doing an if statement in one line. I don't like that, but it's basically like that. So basically what this is saying is x is 12. Is 12 greater or equal than 5? Yes. So the first thing after the question mark gets selected. Otherwise, it's gonna be x. Since 12 is greater or equal than 5, a is gonna be selected, so y will be equals to 8. Okay. So I don't like that because it's not very clear. Maybe someone coming from another programming language might get confused. We can have if statements inside of other if statements, so that might get things confused. So basically you do two checks. So first, is x greater than 22? Yes. If it's greater than 22, let's check if it's greater than 31. So 37 is greater than 22, so we're gonna go inside of here. It is greater than 31, so we're gonna printf that x is greater than 22 and 31. And if we have multiple if and else conditions, we have something called else if. So basically it's when you have multiple conditions. So if a is 23, print you're awesome. Else if a is 24, print something else. So I can say printf, you are great. So I can have multiple conditions. Let me do \n, save. Let's make this 24. So now it's gonna print your grade, because it's not gonna be equals to 23 because we added 1. It's gonna be 24. Okay, you are great because of this. All right, so if num is greater than 0, print positive, else if num less than 0, print negative, else print 0. So all the possible scenarios. All right, we're making progress here, guys. Let's go. Switch statement is basically when we have multiple cases. It's like when it's pretty long, you can use a switch statement. Not so common. So for example, hey, is num 1? If it is, print 1. Case 2. So if num is 2, print 2. If num is 3, print 3. It's a different way of doing if and else statements. That's not so common, but you can see that. So it always has a default case. So it starts by saying switch num. If num is 3, print a prime number. If num is 5, print another prime number. And then you call this word called break afterwards. We'll probably see what that means pretty soon. Logical operators, so very important. And so this is 2 ampersands, or it's 2 lines. So for example, if I want to check if a is greater than 23, that's only, so it's a greater than 22 and a less than 25, print you're awesome, something like that. Otherwise, else, print, let me remove the else if. So if it's between, if greater or equals than 23 and less or equal 25, print you're awesome, else print you're okay. So we can have print and else statements. Let me zoom out so you guys can see. If a greater or equals than 23, okay. Let me run this. You are awesome. You are awesome. Okay. Awesome. So let's see how that works. So fill in the blanks to print yes if n is a non-negative value number less than 100. So we need to check if n is greater than 0 and if it's less than 100. And then we have the OR. So the OR, the end works like that. If both conditions are true, that's true. If neither one of them is true, it's false. A NOR operator, only one condition has to be true. So if n is lowercase, wait, what is, okay. If n is lowercase x or n is uppercase x, print Roman. So one of them has to be true, not both. In n, both have to be true. And then we have the not operator. So basically, it's saying like, if we're gonna see. So int x equals 3. So x is 3, y is 8. Is x greater than 2? Yes, true. So only one condition here has to be true. Since x is greater than 2, since x is 3, this will be true. But this exclamation mark flips from true to false. So since this is true, with the exclamation mark this becomes false. So we're not gonna print true, we're gonna print false. Okay. Let's go. And then we have loops. So loops are a way for us to do something multiple times. So instead of saying, for example, hello world, I can say something like that. So you guys will see. I can say, hello world. Hello world. Hello world. hello world. That's not very efficient, but it's gonna work, right? But think, let's say we want to do something 100 times. It's not very efficient to copy and paste. It's gonna take a long time. So this will print hello world 4 times. So if we run this, hello world, don't forget the \n. \n, 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 okay? Let's go. So make programming. Hello world. So that's very inefficient. What I can do is do a while loop. So I say, hey, let's create a variable called y. While I is less than 4, why don't we print hello world? So we just have to define this once, and then it's gonna keep on repeating. So this will keep on repeating until my I is 4, because the condition is while less than 4. So if I need to add 1 to my I, otherwise we're gonna have an infinite loop, because this condition here will never be false. So basically I'll print hello world multiple times, but now with a loop. I have just to define this once, and then I'm good to go. The loop structure takes care of it. But you can't forget semicolon, So let's do programming. Hello world. My 2 biggest problems, the semicolon and the \n. So now, if I run again, and I run the program, hello world, I don't know why there is an S, because I put an S. But you got the idea. So basically it's a loop. It's something that happens over and over again. So I can say, for example, n equals 0, while n is less than 5, print hello, n++. So that will repeat multiple times. There is the do while loop. So what I recommend you guys doing is to try CS50. CS50 is a course from Harvard. Type CS50. This is the best way for you to learn programming. This course, Solo Learn, will give you an introduction, but you need hard problems to solidify what you're learning. One of the problems they ask you to do is called Mario. By the way, we have a solution here on the channel. And they ask you to do a do while. So the do while is interesting because a while loop keeps on repeating. But if the condition is not true, you're not even gonna get inside of the while loop. A do while runs once and then checks the condition. So you have the guarantee it's gonna run at least once. So for example, in this case, count is 1. We're gonna do and then check. So you're gonna print. So how many numbers will the following code output? So we're gonna print 1. Increment count by 1. So now count will be 2. Then we're gonna print 2. We're gonna print 3, 4. So 1, 2, 3, 4, 5, 6, 7, 8. So we're gonna print 8 times. Or not really. Why don't we test this? So we can do int, what's the value? Count equals 1. Count equals 1. Nothing better than making the computer do the work, because it's late and I'm making some weird mistakes. So let's print count, and then what's the condition? Count less than 8. Count less than 8. Okay, so when you are not smart enough, you use the computer. That's why programming is great. So we run, Oops, infinite loop. This is great. No, no. Infinite loop. Okay, so this is great. Why did we get an infinite loop? Because I'm not incrementing my counter. I need to say count plus plus. Otherwise, the condition will never be met. And let's not forget the backslash n. So the formatting is nice. So now you guys saw your first infinite loop. So 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. 7 times is the answer. 7 times. Alright? And we can break. So break is something that you break, you get out of the loop. So I can have a loop like while count equals less than 10. Print something, let's say print count. We're gonna print count backslash n backslash where are you? But I have to use the other. Okay, we're gonna print count plus plus, but let's do a condition here that if count equals 5, we're gonna break. So that means we'll never reach 10. We're gonna exit out of the loop when count equals 5. So let's compile. What's going on? There is a typo, Printf. And let's run. 1, 2, 3, 4. Why? Because when count became 5, I broke from the loop. So break serves this purpose and continues. So fill in the blanks to break from the loop. So if num, when it becomes 2, is 2, I break. And I print and go down. Okay. So let's go, we're approaching 1 hour for loops. Let's see how much we have. We are approaching we're approaching 4 loops. Let's go. So 4 is like a while loop, but you do something multiple times. So 4x equals, so this is the initial condition. This is the ending condition, and then we increment 1 at every iteration. So I'm gonna show you guys so what does he want us to do? From 0 to 5. So we print x. So let's print that using a while loop. So it's very similar to a while loop, but we can do everything in one line. So we say that our counter starts at 0. While our counter is less than 5, we're gonna keep doing something, and at the end of every iteration we make I increment by 1, so we don't have an infinite loop. So we're gonna print hello \n semicolon. We're gonna compile and run. Hello, 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 hello 5 times. So my for loop is doing the same thing multiple times for us. Okay? So you can have nested for loops. So that's pretty interesting. So how many times will this loop run? 0, 1, 2, 3, 4, 5 times. Right? So now we have the quiz. So remember, scanf helps us get the value for a variable on the terminal, on the black screen. So the user will do that. So basically we put here %age. Output rings allowed if age is greater than 21. So if age is greater than 21, print rings aloud. Else if age is less than 10, study math. Fill in the blanks to print the number 0 through 5 using a do-while loop. So the structure of a do-while is you have a do. So int c equals 0, do. We're gonna print the number, increment the counter, which is c, by 1. And then we have the condition at the bottom and we put a semicolon. Print solo learn 3 times. So we have a for loop. My counter starts at 0. While I is less than 3, I'm going to print solo learn and increment by 1 at every iteration. If I have multiple conditions, I can use a switch statement. So I can break. If num is 1, I'm going to print 1. And if it's 2, I'm going to print 2 and break. So this is like a loop. I'm exiting out of the switch. So that's why I have a break. For age greater than, so I want to drive if if age is greater than 17 and less than 19. So I'll have 2 ampersands. Oops, what happened? Oh, it's an if statement. I don't know. So forget about this. This is if age is greater than 17 and age is less than 99, print I can drive. If. Awesome. Woof. Okay. So now functions. We're making progress, guys. Okay. Let's take a minute to maybe drink some water. We're gonna go to functions, arrays, and pointers. So let's do the rest. So there is functions now in C. So let's go to functions. Very important topic. Makes your code easier to understand. So for example, if I want to take the square, instead of having all the code for square in my main function, I can call it. So we'll see what calling means. So C must have at least one function called main. So we've been seeing main is a function. So it's the first function that the compiler is gonna look for to see how your program works, but it's a function. So a function is you can recognize this because it has a name like main. It has parentheses after the name of the function. It has a type, so it's an int, a char, a float, and sometimes it has a parameter. When you create a function, you need to declare at the top. So after the include, you say the kind of function you want in C. And after you declare here at the top, you can define here at the bottom. So you can just say int square, int num, and then do the calculation, and then that's it. You need to put here at the top. So now let's take a look at a function. So I create a function called int square. It's gonna take the square of a number. So let's say num. Okay. So that will return. So return is what you get back after calling this function. So we'll see what calling means. But we need to have this at the top. So after defining, I put this at the top. And now I can call a function. So calling means I can use that function. So let's call it current num. My keyboard is failing me. So current num equals. Now we can call square and pass a value. That value will be squared because we define it here. It's gonna return it. And then we're gonna print current num. So let's print current num. Okay. Just want to make sure that this was working. Programming. We have a problem. What's the problem? Because we need to define the variable outside of a for loop. We can't have that inside of a for loop. So we say int current num and then we can use that inside of my for loop. So make programming. What's the next problem? Current num typo. That's the problem. So problem fixed, and we can now get the squares of the numbers from 0 to 4. So observe, I don't have the code inside of my main. I can just call the function and get the result. So that's pretty cool. So it gets an input. So the input, we need to tell the kind of the type we have. So it's a num. We will say that y will be num times 3. And then we return the value of y. So return is what the function that calls you gets. You return. Calling a function is this. So you use the it's just like printf. You use the name of the function. You pass in a value in parentheses if the function is expecting a value. And that's it. So what's inside of the parentheses is called a parameter. And what's passed are arguments. Okay? So these are my arguments, x and y. So taking two float parameters. So float, float. Those are my parameters. And what's a scope? So a scope is where the value exists. If I declare it outside of main, like global 1, I can access global 1 anywhere in my code. But local 1, local 2, outside of main, it doesn't work. So variable scope refers to the visibility of variables within the program. And then we have static. So static exists throughout the program life. So for example, where is a static variable? So num calls. This won't, so usually when you call a function, after you exit the function, this variable will get disappeared. But with a static variable, it's gonna be remembered. So let's see how do we call this static? So static is a more advanced concept, but the idea is the following. If I say int x equals 0, return x plus equals 1. So okay, I'll call this add1. I need to change the name, add1. Add1. You guys will see what static means in a second. Oops. Make programming. Okay, programming. 1, 1, 1, 1. If we declare this as static, static x, let me just see how he does. Okay, equals 1, return x, and then I do x plus equals 1, return x. Let me see if, I don't think this will work because I'm reassigning 0. Let me just see one thing, what he does. I want to see his example. So he declares static here, and then he increments. Okay. Let me just see where num calls is located. Hello numbers. Yes. Okay. Okay. So we're gonna print. So we don't return anything. We just print x. I'll explain to you guys 1 second. You guys will see. And then I just call add1. So let me change this to void. So void means there is no returning thing. Printf implicit, yes, typo, printf. Make programming forgot the semicolon. Make programming. So 1, 2, 3, 4, 5. Let's put a \n. Make programming. So 1, 2, 3, 4, 5. So now let's remove the static. Make programming. 1, 1, 1, 1, 1. So static declares once, and then it kind of saves the value every time you call the function. If you don't call it static, it gets reinitialized every time you call the function. So every time you call add 1, it becomes 0 again, and then you add 1 and print. That's why you get 1, 1, 1 when you don't declare static, and 1, 2, 3, 4, 5 when you declare static. So that's important to know, but not super important, but important to know if you're more intermediate to advanced. Okay, so I'm just looking down to see the battery of the microphone. So recursive functions, this is complicated if you're a beginner. So this is a way for you to call the function multiple times. So for example, you can define a function called factorial. So a factorial is a recursive function. If num is equals 1, we return 1. If you don't understand this, don't worry, I did understand the first time someone explained this to me. I return, so I'll call this factorial now, factorial, and this will return an integer. So this will return factorial num minus 1, and then my current num. So if you don't understand, don't worry, this is not so used, this is more used in like an algorithms course, but the idea is we keep on calling the function with 1 less than the current value. So we keep calling until we reach the value of 1. Then it's gonna return 1, and then we keep on adding to num. So that's a recursive function, factorial. So for example, int num, let me change this to factorial, and then num equals factorial. What's the factorial of 5? I don't know. Of 4. Printf d. So this is not a course on factorials, we're just showing you. So if you want to understand more about factorial, I recommend taking a more comprehensive course, but it's good to know. So what's a factorial? It's 5 times 4 times 3 times 2. So factorial 4 is 4 times 3, 12 times 2. So 4 times 3, 12 times 2, 24 times 1, 24. So there is something wrong with my code here. So let me just see factorial. Factorial of 2. Oh yeah, because it's not plus, it's times. So now it's gonna give us the right value. Let me put \n. Make programming. So a recursive function is a function that calls itself. It is kind of 24, so it's kind of weird. I recommend you look at a recursion tutorial to get deeper on that. But it's not important to become a developer. Most developers don't understand factorial because it's not so used. It's not really used in 99.9% of cases. But it's good to know it exists. Arrays are really important. So arrays are lists of things. So you need to also declare the type. So if I want a list of integers, 25 integers, I say int test scores that will have 25 elements. Or I want a list of 5 decimal points that's gonna be called prices. So he wants to declare an array of integers, so int x4, and the values, the 4 values will be, so if you wanna define the values, you put in curly braces. So this is kind of weird. The first element of an array starts at 0. So in computer science, you start accessing things with the 0th element. So 0, 1, 2, 3, 4. So for example, the 5th element of this list is 0, 1, 2, 3, 4. It doesn't exist, so this would give me an error. So let's create a list here. So let me remove this function. Thank you, Factorial. You were useful. No, not so useful. So I want to create a list of 4 elements. Those elements will be 1, 2, 3, 4. No, let me create some random numbers. 15, 5, 3. And now if I want to access the first element, I can say num 0. So the first element, the index, so this is called an index, is 0. So that's the first element. So programming 20, which is the first element in C. Okay, so if I want to print the second element, the second element has index 1 because we start counting at 0. Okay? Alright, so let's continue. So we can use loops with function, with arrays. So for example, I can like loop through the values of an array. So I can say something. So how many items do I have in this array? 4. So then I print the current value. So what's the current value? I. The current value of my list. So it loops through every single element, 20, 15, 5, and 3. We can use loops with arrays. So I can say for I less than 5, print the x is my index element. I can print each element by saying rx. Okay. We can have 2D arrays, so that's like a matrix. So remember from high school. So how many elements can the following array hold? 1, right? No? Okay, he's declaring an array that has 2 rows and 5 columns. I thought he was saying like, how many elements is that? 2, 5. So that's 2 times 5, it's like a 2D array matrix, so that's 10 elements. Okay, so the way to access it is pretty straightforward. If I want to access the first row, that's the 0th row, the second row is index 1. If I want to get 2, that's 0, 1. So, okay, that's a complicated problem. So let's take a look. Calculate the output, the sum of the elements in the array. So I have a for loop. So this is called a nested for loop, a loop inside of a loop. So since this goes up to 2, that's looping over the rows. This goes up to 3, so that loops over the columns. So I want to add to sum my current row, current column. And that's gonna add all the values, and then I'm gonna print sum. Alright, let's go. So now memory. So when you use the ampersand, you are accessing the memory address of num. So num is stored somewhere in memory. It has like a weird value, and that's what we're printing when we say scanf num. So scanf basically says, hey, whatever the user writes at the terminal, put at the address of num. So that's why we do %d and then we use ampersand, because we want to store the value of 42 in the over there. So he wants us to print the hexadecimal. I didn't read. So to get the hexadecimal, we say x. So let's see that on the terminal. So that's the address in memory. of that value. So int x equals 4, printf %x. So instead of printing 4, we want to print the address of x, which is a hexadecimal. Let's actually call this something else so you guys can different %x from the variable. So this will print a really weird value. %x. What's going on? Let me see, I never use this %x. Let me see how he does it. %I. That looks good. Why is this not working? Do you just put the variable? %x. Format type, but the argument type int. Int a, did I save? For some reason he's not recognizing the %. %x. Does %x exist? %xc. So Googling is always a good way, so you can look at Stack Overflow. So this should work, right? Let's actually copy this. Why not? Let's see if this works. And if it does work, I want to know why it didn't work before. It did work. So this is the address of the value of data. Maybe I forgot the semicolon or something. Oh, I forgot to remove this. I think this was messing up. Okay, so 1D is the address of that particular variable. So I can get, so the address of var, not the value of var. So what is a pointer? So pointers is very important in C because you can play with memory. So that's something we're not so used to in other programming languages. So it's a pointer is a variable that contains the address of another variable. So instead of holding values, so for example, data stores a value, 29. We're gonna store the address, so we're gonna store 1D. So this is kind of tricky. So this is actually a good example. So for example, if I say int star, so to represent a pointer, I put a star. And I say %data. So now P stores 1D because this ampersand gets the address of data, and now P is a variable that stores the address of data, and the star represents that as a pointer. So I can now print P. So to print a pointer, you use %P, if I'm not mistaken. I'm not mistaken this time. So actually the address of data, the complete address is this thing here. It's 17FFFA. And if I want to get the value of P, I can do something called dereferencing. So I put a star before the P. So this is like a pretty complicated topic. 29 pointers. So what do I recommend to you if you want to understand more? So I'm assuming you guys know about pointers, maybe from another programming language, C++, or from a course in college. If you want to know more about pointers, I recommend you take the course CS50. Subscribe to the mailing list here on the description, where I'll always give tips on programming. But the best way is to take CS50. CS50 has a chapter, a whole week, where they teach pointers. It takes time, so you won't learn deeply about pointers here, because if I talk about pointers, it's gonna take a long time, and it's already gonna take like 3 hours. But the idea is a pointer is a variable that stores addresses, and so we put a star and we put ampersand. So basically I'm storing PTR, the address of the variable var. So he's talking about pointers in expressions. You can use expressions just as any variable. Other programming languages hide this idea of pointers. We can have pointers in an array. So basically I have an array with 5 elements, a pointer that's we declare it starting at null, and then we basically do some pointer arithmetic, so we can like point to each element of the array, which is pretty cool. So basically right now ptr is pointing to my array. When you point a pointer to an array, point a pointer when you point a pointer to an array, it always points to the first value. So this is pointing right now to 22. When you add 2 to a pointer, it basically adds the size of the type to that value. So it basically skips to the other value twice. So you go 22, 33, 44. And that's gonna print the value at address of the second spot in the array, the value, and you're gonna get the value because you have the star before. That's called dereferencing. So that's gonna print 44. If you didn't understand, take CS50. But remember, so ptr is pointing to 22. You add 2 to the address, so that takes us to the address of 44. Star gets the value at the address of 44, so that's called dereferencing. That's why we got 34. And then we can have a bunch of arithmetic with pointers. So again, ptr is pointing to the address at 1, because when we point a pointer to r, it points to the first place in the array. So he wants to increase the pointer using the increment operator. When we do plus plus, now my pointer will point to 2. And we want to output the value. So then we dereference. And so dereference means getting the value at that address. And that should work. And then pointers with functions. So they have a certain relationship, because you can basically pass the address of the variables to functions instead of the values themselves. So for example, if I call a function in C sending x and y without a pointer, that's gonna swap the values, but since the scope of the function is local, we're not gonna swap the original values. We're gonna swap copies of the original values. So this is called pass by value. If we wanna actually switch x and y, we need to pass the address to the function. And then by passing the address, we're gonna actually do the swap on the original values. So we can analyze this here. So basically, we're passing an address. So this is all complicated. CS50 is the key for you to understand this. So what is the output of this code? So my variable v equals 8. I pass the address of v to test. So then I'm pointing this pointer to the address of v. I'm dereferencing this. So when I dereference this address, I get the value at v, so 8. 8 divided by 2, 4. So I'm adding 4 to 8. So now my value of x will be 12. And x is pointing to v. So now the value of v will be 12. When I print, this will become 12. All right. Okay. So now we can pass, an array cannot be passed by value to a function, but the array name is a pointer to the first value of the array, like I said. Like the orders is nothing more than a pointer to 100. So just by passing the array name to a function is passing a pointer to the array. So for example, when we pass add up orders, we're passing a pointer. So that's why he says int star a, and then an integer, int num elements. So basically, we are passing a pointer. So we can do something very interesting, which is basically we pause. So a is my pointer to an array. So I can say a k, that's each value inside of the function. So let's see. So let's say I create an array, int r4. It has 2 values, 1, 2, 3, 4. Okay. And then I'm gonna create a function called loop that doesn't return anything and accepts a pointer because r is a pointer. And I'm just gonna loop through this array for, so I can just say printf %d \n r I, and then I need to put this at the top so the compiler knows I created a function. Okay, make programming. I'm not calling the function, that's why nothing's happened. So I need to call the function. Now it's gonna work. Make programming 1, 2, 3, 4, 5. So observe, if I took the star, this wouldn't work because arrays can't be passed by value. So it complains. So I need to have the star to show that I'm passing a pointer. So filling the blanks should declare a full taking an array as a parameter returns an integer. So since it returns an integer, that's the type here on the left hand side of the name function name is the type that's gonna be returned. Since my input is an array, that's a pointer, so int star. So functions that return an array. So just as pointers to an array can be passed into a function, an array can be returned. So how do you return it? You can just signify that you return an array by putting int star. So if you say something like int star here, the compiler will know that you're returning an array. You're returning an array when you call the function. So for example, here he knows that if you call get evens, you're gonna return an array, in this case nums. So a will be a pointer to an array, that's what's gonna be returned, an array, so you create a as a pointer. So you see how function arrays, calling a function with an array is complicated. So if you can avoid it. So int type in that declares a function, return an int array, so int star get array. So that returns a integer. Okay, I think we're in the quiz. So filling the blank should declare a function taking 2 integer arguments and returning a float value. So if we return a float, that's it, and then it returns 2 integers as an argument. So 2 arguments. Filling the blank should define a recursive print function that prints numbers from n to 0. So if n is less than 0, we print the value and then we call the function with the argument of n plus 1. So we're printing like 5, 4, 3, 2, 1 until it's 0. Oops, what happened here? Let me try again. So float int b. Okay. So he's saying recursive function that prints the numbers from n to, so this is recursively called, so that's good. I didn't understand this. If n less than 0, oh yeah, he's asking for a return. Return, that's it. No? Print the numbers from n to 0. So we're gonna print n and then print the function. Oh, we return 0. Retry. Return 0. Filling the blanks. This is confusing. So if n is less than prints numbers from n to 0. Huh. So print, the name of the function is print n minus 1, print f%dn. I'd say that if it's less than 0, you just return, because you're done. I don't know, yeah, I didn't write this previously. Okay, filling the blanks to print the elements of the array. So for, you have a for loop, and to access each element of the array, R. Filling the blanks to declare a pointer has a star, and double its value via the pointer, double its value. So a pointer points to an address. To get address, use ampersand. He wants us to double its value. So to double the value, you need to dereference PTR. So this will get the value of 42 times equals 2 and reassign it to PTR. So swap takes 2 pointers and then we swap. So this is the algorithm to swap 2 values. Retry. Oh yeah. So the value at B now will be temp. What is the output of this code? So this is a static. So okay, so we're calling a function called test. Test will return a array. We know it because of the parameter here. So he's calling this array, and it's a static array. And for each element, we're gonna say if it's divisible by 2. So 0, is it divisible by 2? Yes. So what's the rest of 0 modulo 2? 0. 1 modulo 2, 1. So it's gonna be 0, 1, 0, 1. When we return, we're gonna return 0, 1, 0, 1 as a list. This is a good value, good problem. So 0, 1, 0, 1. What's gonna be stored at the third element? So that's the last element, 0, 1, 0, 1. So it's gonna print 1 because we're dereferencing the address at the last spot at the array. So it will be 1, 0, 1, 0, 1. Okay, all right. So now strings. So let's go. This is a shorter chapter. So strings are arrays of characters, and you always end a string with the no character. So string actually has 1, 2, 3, 4, 5, 6, 7 plus the no character. So if you look at the size, world you would think world has size 5 because it has 1, 2, 3, 4, 5 letters, but it actually has 6 because every string has this \0. This is a rule for, so when you want to create an array, you always need to put a \0 at the end. So how do you declare fill in the blank should declare a string as a char array. So string is always an array of chars. To get an integer, to get a string as an input, you can use scanf gets or fgets. So there are multiple ways. So you can create a char array, and then you can use that, or you can use gets, or you can use fgets, and then you have a second parameter. I feel like gets is the easiest one, because you just declare the array and then you say gets, and that's it. You don't need like second parameter, blah blah blah. So here we declare a char array with 20 elements, and then we do %str. No? Let me see. We do %. I never use scanf. Char blah blah blah. Scanf. Let me see. Scanf. So this is a char. And then str, it's not str. Yeah, why it didn't work? Strings output is handled by fputs, puts printf functions. Fputs requires the name of the string and pointer to where you want the string to print the string. To print the string, use stdout, which refers to the standard output. So yeah, this is really low level stuff. Like stdout is basically related to a file descriptor. This is like really low level, so don't worry too much about this. I just use printf. But anyway, he wants us to practice, so let's practice. So how does it work? I've never used fputs, to be honest. It's not really common. So so char, and then fputs, the name of the variable name, and the output, stdout. Okay, learned something new with you guys. String functions. So there are some functions the string provide. As printf, that's an important one if you take CS50. So as printf will print info, so that's a buffer. So you're basically printing, so this is the string, the %s, that's the department. Where's department? No, %s depth, so that's HR. The HR department has 75 employees, and then you're gonna put that into the info char array, and then you're gonna print it. That's which of the following should build a string as printf. That's very interesting. Like, C is a complicated language. If you're learning this as a first programming language, it is hard. I think Python is better. But if you're taking CS50, aka best course in the world, then learn C, but you don't need to go super deep, like learn as you go. Anyway, you can use string.h, which has a bunch of functions. For example, strlen, which is really useful because strlen gives you the size of the string. So to have access to something like strlen, you can say string.h. So on top of stdio.h, you have string.h. We can convert a string to an integer using this function called atoy. So if you wanna turn the number 3 as a string to the integer 3, we can use atoy. This is actually a famous algorithms problem, how to implement the atoy function. So we can use atoy. So now 123, which was previously a char array, now becomes an integer and you can print it. We can have an array of strings. So it's actually a 2D array of arrays. Crazy. So we can have an array of strings. And since we have to have the longest array, so the longest word in my array has to be the one on the second spot. This is like not so common. Char array names 3. How many elements does this have? Oh yeah, it has to be the longest. Char names, so that's 3 rows, and the longest has 1, 2, 3, 4, 5. Wait, let me see. Using char, okay, using the pointer. Using the pointer, I don't need to say how long it is, so I can just say char open close parentheses. Nice, that's nice. I don't need to lose time with that. Function pointers, let's go. Let me see how far we have. Okay, let's go. So function pointers, so since pointers can point to an address in any memory location, it can also point to the start of executable. So we have pointers to functions. Alright, I don't know how that works. So let's learn together. A function pointer declaration uses the star just as you would with any pointer. So, okay. So the parentheses around are important. Without them, the compiler will think that the function is returning a pointer. After declaring the function pointer, you must assign it to a function. Okay, so let's see. So funcPTR is a pointer to a function. So it points, so void funcPTR int, say hello. So it's a pointer to a function that has int as a parameter, I think that's the case, and has a void as a return type. So then I point funcPTR to the function say hello, and then I can call the function funcPTR with a parameter. So I can use the pointer to a function. So in JavaScript, we kind of do that, right? So if you've ever played with JavaScript, we can have a variable that stores a function. I think that's what's going on in the background. You have a pointer to a function, and you can use that variable to call the function. Very interesting. So a function name points to the start of the executable code, just as an array name points to its first element. Therefore, although the statements such as funcPTR, ampersand say hello, and funcPTR are correct, it isn't necessary, blah blah blah. Okay, so return, fill in the blank to return a function sum returning the sum of its arguments. So a plus b, and declare a function pointer psum pointing to sum. So this is a, so I suppose this is a pointer to the function sum. Alright, I learned a new thing with you guys. Array of function pointers, the guys are creative. Jesus Christ. I've never seen this, and I've done C for a while now. Okay, so I have a, okay, let's go. So this is a pointer OP to a function that takes 2 parameters of integers and returns an integer, which is the case for add, subtract, multiply, and divide. So I can have an array of pointers to functions. That makes sense. So OP points to, is a pointer that points to the add function. So each slot in the array is a pointer to a function. Okay, nice. So we can then enter 2 integers that will be stored in X and Y. And we can then, what are we doing here? Scanf choice. Okay, so interesting. This is an interesting problem. So we scanf if we want like 0, so 0 will be add, 1 will be subtract, so we can select the function, and then this result op choice xy will pick the function where that's gonna be applied. So that's kind of useful for us to understand like how JavaScript works, because in the background that's what's going on. We have a pointer to a function. Interesting. Or even Python, very interesting. So this is a function of pointers to so this is an array of pointers to functions that have no parameter and have void. So what we're gonna do is loop 3 times, and then we're gonna call funcs. We're gonna call all those functions. Nice. This is interesting. It's good to see. It's hard, but you really understand how things work on the background. So let me see the battery. We're good. So a void pointer is used to refer to any address type in memory, has a declaration that looks like that. So this I've seen before, void star ptr. The following program uses the same pointer to 3 different data types. So I have an integer, a float, so integer is an integer, float is a decimal point, char is a letter, and then I have a pointer, a void pointer. So I can point the pointer, I love this expression, point the pointer, to x, to I, so I can use that pointer to point to any type. And then I can typecast, because if it's an integer, I can make that ptr now a integer. I see. So that's good in case, I don't know, we don't know what will be returned, what type will be returned, because this is, the void is very general. So if you call something, I don't know, in your operating system, and you don't know if you're gonna return an integer or a char or anything like that. So this is really advanced, guys. If you're here in the tutorial to learn the basics, you are basically done, I think. Unless you're a professor, you're taking like a more advanced course, you're familiar with programming. But if you want to learn the advanced stuff, that's pretty cool. So basically this is casting to, so this makes it general. Like you call a function in your operating system, you don't know if it's going to return an integer, a char, a float. You declare the pointer as void, and then you can know what to do later. You can say, hey, if it's an integer, you can do this. So that's integer. That's integer. That's interesting. So a void star ptr, and then we cast that to a integer. No? No. No? ptr, that's the only option available. Okay. So functions using void pointers. Void pointers are used for function declarations. Okay. Using a void return type allows for any return type. Similarly, parameters are void except any argument type. So that's what I was saying, like if you call a function in your operating system, like you don't know what you're gonna return, you declare it void, because then you can like return anything. And a void, so a void parameter also you can accept anything. So that's good, because you can leave out the parameter name to further insulate the declaration from its implementation. So you can customize later without changing the declaration. So for example, void square, you can like, the way you're gonna implement the function is up to you. But you see that he casts the parameter to an int later. So he casts num to an int pointer, and then the reference. Jesus Christ, this is crazy. If I wasn't familiar with pointers before, I have no idea what's going on here. But I'm kind of getting it. So void, Typing the result to declare a function that takes a function and returns a void pointer. Typing a function that takes and returns void pointers. Void star, yeah, void star. Function pointers as arguments. So another way to use a function pointer is to pass it as an argument to another function. A function pointer used as an argument sometimes referred to as a callback function because the receiving function calls it back. So another reference to JavaScript, it has the idea of callback. The QSort function is the standard library header file used this technique. Quicksort is widely used algorithm for sorting an array. To implement the sort in your program, you need only to include stdlib.h. So QSort has a bunch of void. So it's one of the parameters is a void pointer. So you have a void pace, which is a void pointer to the array. Size tnum, the number of elements in the array. Size twidth, the size of an element. Int compare, a function pointer which has two arguments and returns 0 when the arguments have the same value. Okay, so the actual implementation of the compare function is up to you. So that's the great thing about declaring void, is that it's general. So for example, you call it with, you define the compare function. So you say, hey, a value is equal if the two integers are equal. If the first is less than the second, it's negative, otherwise it's 1. So the great thing is, since we declare this as a void, it's general enough we can customize it. And then it expects an int. So this so that's the purpose of the void star. That's something I've seen before, the void star, and I never understood, but now it makes sense. I can customize it to my needs. So if I want to make this as like a char, I want to make be comparing chars, I can customize it to compare chars. So a function pointer used as an argument is sometimes referred to a callback function. Just want to see what this callback idea is. A function pointer used as an argument. Okay, so for example, callback is our function, it's our callback function. That makes sense because the receiving function calls it back. So quicksort will call compare back. So that's why it's called a callback. Complicated stuff. C is not for beginners, at least not at this level. Fill in the blanks should declare two strings and assign values from inputs using scanf function. So char str1 20, char str2. So fill in the blanks should declare two strings and assign values from input using scanf. So this is scanf %s. So we'll write two strings, and each string, first string will be assigned to str1, second to str2. Fill in the blanks to convert the input string to a number. So that's easy. We're still not. So gets number, a toy number. Fill in the blanks to declare a function that returns the square of its argument. Call it with the value of 42 using a function pointer. A function pointer. So this is a function pointer. It returns an int and it accepts as parameter an n. So we're assigning square to this pointer. So when we say fp, so we return n plus n, fp, call it with the value of 42. Okay. So when I say fp42, actually square will be called because we assigned that to the pointer. So this is a pointer to a function. Just want to make sure. Pointer to a function. So we're storing this function as a pointer. Alright. Fill in the blanks to triple the value of the num via the void pointer. So the void pointer, I will point to ampersand num, so the address at num, and now I cast the void pointer to a float pointer, and I dereference this float pointer to the value and multiply by 3. This is hard, guys. This is, if you're following so far and you're understanding, I take my hat to you. These are hard stuff. Okay, let's do it. I still have battery. Feeling that it's 4:12. Oh god, my sleep schedule. Filling the blanks should declare an array of void pointers to x1, x2, and x3 and print them using the pointers. I've said pointers today 100 times. So x1, x2, x3, we have a void pointer. So this is great because I can have an array with multiple types. I didn't know that. So then what we can do is we need to have the correct identifier. So the first one is an integer, the second is a float, but we can have multiple types. And this is, oh my god. Okay, so this I cast the void pointer to an int and I dereference a float pointer, and this is a char dereference pointer, and I scanf. Okay. No! Is it just printing? It's just printing. Okay. Guys, this was hard. I'm not gonna lie. I didn't know this void pointer to functions, but I'm happy I learned something new. Hope you guys learned something new today as well. So structs I know. I think I'm good. So let's do structs. Let's continue. Let's not lose our momentum. We have momentum. So a structure is a user-defined data type. So int, char, float, those are types that were given to us, but we can define our own types. So a course, we can define a course type that has an ID. It has a string called title with 40 elements and a float hours. So how do you declare? Use the struct keyword, and then you, what's missing here? Semicolon. Should declare variables of a structure. You type the keyword struct followed by the struct tag. So that's good. So this is how we're declaring. We say struct student int age, int grade. So this struct has age, grade, and name. And then we declare those variables. I'll type in the CS50 ID pretty soon. So to declare a human struct with the variable h1, I do it like that. I can declare structures, so each one will be one of the values, right? So for example, I don't know, the age will be 19, the ID will be something, so on and so forth. So those are different ways of declaring. So I can cast it, I didn't know. If you want to initialize a structure using curly braces after you declare it, okay, so there are two ways. I can either do this or I can cast. After. Okay, so this is in the same line. So since I declared the reference here, if I wanna later start it, I have to do this. But this is kind of complicated. So this is useful. So if I wanna access an element, I use the dot operator. So for example, I wanna overwrite the ID from this number to this number. So I can use cs2.id, now is this. So I'm overwriting that value. He's copying advanced C++ to cs2.title and declaring cs2 hours to 14.5. Okay, so struct human h1, h1.h plus equals 2. Type def, that's pretty useful stuff. So uses a case definition, simplifies the code. So instead of saying struct course CS1, you can call just course. You can say just course. So type, you're giving a name, type def. You can declare it more easily just with the human word. So this is very similar to class in other programming languages. So for example, this is a circle, this is a point, and you can have a struct inside of a struct. So observe that we have a struct inside of the circle, a point inside of the circle, and we can declare them inside of each other. So I can have, having the blank structure, so this is a type def struct called small, and a member called s. What's that, an integer? Having, oh no, so we want to have a small struct inside of big. Now, next level stuff, we have a pointer to a struct. So just like pointers to variables, pointers to structures can be defined like that. So struct, my struct, blah blah blah, defines a pointer to the my struct. Struct ptr stores the address of the struct. So if I want to access, so we can only, a pointer is a pointer to an address. So to get a certain property, we need to dereference that address, then use the dot operator. But that's kind of like two things, and that's too cumbersome. So this arrow was created to make our lives easier. It's basically dereferencing the pointer, and then and then accessing it. So struct pointer, so this is a point. So I'm created a pointer that points to the struct. This sets the x property of point to 3, and then I wanna set ptr to 4. I also use the arrow. A function can have structure parameters that accept arguments by value. When a copy of the structure is available, like, let me take a deep breath, guys. This is a lot. This is hardcore stuff. So struct, okay, let's go. So a function can have structure parameters that accepts arguments by value. When a copy of the structure variable is all that is needed. For a function to change the actual values in a struct variable, pointer pointer parameters are required. So I can have a function that takes a pointer to a pointer to a struct. For a function to change the actual values in a struct, pointer parameters are required. Array of structs, so we can have array of structs. So fill in the blank to declare, so this is type def to declare a point struct, and an array of pointer structures. So this is a struct array of, wait, what's missing? Oh yeah, the type. So this is a points. This is an array of structs. Okay. All right, let's go. Unions. So this is, I actually don't know. A union allows to store different data types in the same memory location. It's like a structure because it has members. However, a union uses the same memory location for all its members, and only one member at a time can occupy the memory location. A union declaration I've never seen this, so this is not, I mean, this must have a very specific use case. Oops, I've never seen this before. So a union declaration uses the keyword union. So basically it's a way to save up memory, because it allows different data types in the same memory and all its members occupy the same memory location. So probably this was useful when we didn't have so much memory. But I wouldn't see why to use this right now. Union, how do you call it? Union semicolon. Okay, so don't memorize this. This is not so useful. Never seen this. What's missing? Curly braces. Union, curly braces. Okay. So we use the dot operator, just like we had before. So union val test dot into num2. So this is just like a struct. Structures with unions. Jesus Christ. So unions are often used with structures because the structure can have a member to keep track of which union member stores a value. So this is a union inside of a struct. Okay. So fill in the blank to declare a person struct with a union member. Union. Okay. Okay. Pointers to unions at 4:23 a.m. Last one before the quiz, then I'll continue. I have a Dragon Ball Z shirt. I'll probably have another shirt tomorrow. So working with unions. Pointers to unions, so probably pointers to unions very similar to pointers to structs. So unions is like a more memory efficient struct by what I'm seeing here. So just use structs. So a function can have union parameters that accept values when a copy of the union, blah blah blah. So I'll just ignore this because so union p.id. Okay. Array of unions, so everything's just like a struct. Everything's just like a struct. So I'll just go quickly through this so we can finish. So fill in the blank to declare. So this is the quiz, we're almost done. Fill in the blank to declare time structure with two members, minutes. So this is a struct and we close with curly braces. Fill in the blank to declare struct. So this is a type def. And then, oh no, so not right now. No, yes, type def shape. Fill in the blank to declare pointer to a struct variable. So sh1 ship. So it's an address, and then ship ptr. I think I need to say the type, no, of the pointer. It's a struct pointer. Yes. Declare a union, that useless thing, union values val val.c.val, ignore this. Fill in the blanks union, what's the name of the array? Values, no, nums. So this is nums, this is values. Okay guys, so I'll see you guys. I'll continue. You guys won't see any difference, but I'll probably change my clothes. Okay guys, let's go. So now we're gonna talk about memory management. So in C, we have control a lot over memory. So there is this thing called the stack. That's what happens when you create a new variable. And then there is the heap, which he's talking about here. So when you allocate memory, when you, as a programmer, say, hey, I want more memory, you're asking memory from the heap. So dynamic memory allocation is the process of allocating and freeing memory as necessary. So what can we do? So we need to include this library stdlib.h. The most common function is calloc, but we can also end free. But so malloc, you ask for a certain number of bytes. Free, we free those number of bytes. And then we have a calloc and realloc. So realloc is useful for like, for example, you have an array and you wanna give more memory to the array, you can use realloc. Calloc returns a pointer to a contiguous block of memory that has num items. Each of items typically, I'm mixing calloc with realloc. So calloc is typically using for array structures and other derived data types. Yes, so let's see some examples. So the libraries include stdlib.h. Okay. What's happening? Okay, I think their CSS didn't do a good job. So for example, how do we create a certain number of memory? So we can do malloc and then use size of. So size of will return us the size of what we put in parentheses. In this example, you want 10 spaces equivalent to the size of a pointer to an int. So basically you have 10 spots where you can put pointers. In this example, you're assigning 50 to the second place in the third place to the pointer because we start counting at 0. And that returns a pointer to the allocated memory. So fill in the blanks to allocate 10 bytes, so we use size of. So that will give us 10, wait, fill in the blanks to allocate 10 bytes of memory. 10 bytes. So I just say size of? No. So 10 bytes. So this will give me 10. Does he wants 10 of type int, right? So do I do something like that? No. Let's see. So he wants us to allocate 10 bytes. Star PTR, size of 10, size of star PTR. That's not it. So between parentheses, size of. Size. I really don't know this one. So fill in the blanks to allocate 10 bytes of memory. Let's Google this one. I don't know what's wrong. Oh, malloc. We say malloc, just malloc. Okay. So I was thinking of using the size of function, but if we just say malloc and then the number of bytes, that will give us the correct number of bytes. Okay. So the allocated memory is contiguous and can be treated as an array. Instead of using brackets, pointer arithmetic is used. So the allocated memory is contiguous. The free function will liberate. So after you've used a certain amount, so for example, after I've printed the ptr plus 2, okay, I don't want to pay. So basically this will allocate 50 to ptr plus 2, and then you print it. After your print, you're done, so you can free that code. So int star ptr, and then I can free ptr to free the memory. So calloc, the one where I said we can use to for arrays, allocates memory based on the size of a specific item, such as a structure. So for example, we pass numRecs equals 2, size of records. The program below uses callocs to allocate memory for a structure, so the structure is record. And malloc to allocate memory for the string within the structure. So char info is the string. If you see here, we allocate that to malloc. So num of records basically will be the num of items. So we are allocating memory to the struct. Okay, so basically we have 2 items inside of the struct. We allocate memory to that. So we say, hey, create a struct called record with this size with 2 items. And then we loop through the items and we initialize it. Let me just see if that's what it is. numRecs equals 2. So for k numRecs, recs plus k, what's recs? Is a pointer to the memory that was allocated. So this is the first spot. We'll initialize let me see if I understand what this is. Oh, I see. So calloc will return 2 records structs because numRecs is 2. So I'll create basically 2 structs, and then we're initializing each struct. So the first struct will have value k. The next struct will have malloc to put that string. Okay. So we'll have 2 records for an array of structure elements. So we have an array of 2 structs here. Okay. So I can create fill in the blanks to allocate memory for 3 record structures. So this will be calloc and size of struct record, and then I have an array of structs of record, a pointer to a record. I see. So realloc function expand the current block to include additional memory. So we have a so it leaves the original. So this one is for arrays because the other one was for struct. So for this one, you basically you have an array of size 10. Let's say you want to make size 20. You use realloc. So you add 100 new spots in the array, and then you can play with it. because arrays in C are not, they're fixed, so only with realloc you can give more space. So this will assign r is a pointer to an int. We make that int equals 13, and then we basically increment r to have 2 more spots. So now, before it was just an array with 1 element, so now it has 3 because realloc adds 2 on top of what we had before, which was 1. Then we're copying the value of the first one, which is 13, to the second one. So now the second element of the array is also 13, and when we print it, it will print 13. We printed the first element. And allocating memories for strings is easy. You just use strlen. So strlen str20 times +1. So this +1 is because of the null character. And then we use string copy. That's a very useful function. If we want to copy 1, 2, 3, 4, 5 to str, we can do that. Or str20 to str, we can do that as well. So str copy is useful for that. So fill in the blank to allocate 42 bytes for the str string. So a string is a char pointer, and then I can use malloc. Malloc 42. Is that it? Yeah, 42 bytes. So dynamic arrays, that idea I was talking about of expanding. So many algorithms implement a dynamic array because this allows the number of elements to grow as needed. So in many programming languages, while we talk about arrays, it's a dynamic array. So we have a struct with elements, size, cap, array, and then we initialize them. Adding an element to increases its size. Okay. So we can use what was it? Calloc. So our elements dynamically array uses a structure to keep track of the array size, current capacity, and pointer to the elements. Okay, so this is a dynamic array struct that points to elements, has a size, and has a cap. So size probably keeps track of the current size, cap, how long we want, and elements we can point to the current elements. So we initialize the array having size 0, size of r dot elements, so that will be the size of, I'll allocate one space in memory based on what this dynamic array is pointing to, and then I'll have room for one element. So to expand, I can do realloc r elements 5 plus r dot cap times size of r elements, and then you increase r cap. Just wanna see one thing. Okay, so you're adding 5. Let me see. 5 plus r cap. So if the cap is 6 and I add 5, that's 11 times. Okay, so I'm adding 5 to my current cap and then multiplying that by how many elements I have by the type of the element my struct currently have. So if it's int, it's gonna be 5 plus 6, let's say. My current number is 6, 5 plus 6, times the current number of elements, that's 11. And then I add it to elements. So that will have 11. So I'm increasing by how much I add to my cap. And then I increase the capacity. Okay, makes sense. So fill in the blanks to allocate memory from an array and expand. So I expand realloc R5 size of int. Okay. So now finally the key is fill in the blanks to allocate 10 bytes of memory. So malloc 10, check. Fill in the blank to allocate memory for an integer having the value of 42. So I wanna malloc size of an int. Then I say that the value at PTR is 42 and I print PTR. Fill in the blank to allocate memory for 2 time structures using the calloc function. So I say calloc, so this will create 2 time structs. Size of time. Yes. Fill in the blanks to allocate memory for a 20 character string and assign a value to the string. So char str equals malloc 20, string copy, hello, solo learn, str. Finally, fill in the blanks to create and initialize a dynamic array. So then I say realloc or malloc for this one, malloc, and then I populate that array. Awesome. So let's go. Accessing files. So let's continue. We are almost done. So we have now files, file handling, and preprocessor. So working with files is very useful. If you go through the CS50 course, this will be very useful in problem set 5, where you have to open, close files, read some bytes. So basically use fopen to open a file. There are many modes. You can read a file, you can write it, you can open to append. So those are all really useful. And then in the end you have to close a file. EOF means end of file. So for example, I create a pointer to a file, that's possible. Then the pointer will open a file called myfile.txt for write mode. If it's null, it didn't work, so it's always good to have error checking, and then we close. So that's a pretty straightforward file. So typing the function to open files, that's fopen. Reading for a file, so we need to use, so it comes in the stdio.h. A file can be read 1 character at a time, or an entire string can be read into a character buffer. So that's important, which is typically a char array. We have fgetC, fgets, fscanf. I'm more familiar with fscanf. Fgets returns the next character from the file pointed by fp until end of file is returned. So let's see this one. So I'm more familiar with fscanf. So I have a file pointer, I have a bunch of ints, I have char arrays, and I have a float. I open a file to read. Fgets reads a line. Okay, so that will read a line. Fgets y20. Okay, so we read a line, we print, so that line will be in the buffer, and then we can also use fscanf. Let's see if I understand. Fscanf, I think there is a typo here. I think they wanted to have a parenthesis, yeah. So after fscanf you have a parenthesis, fptr will be the first argument, so the pointer to the file. Then this will have the stock. Stock will be the integer, an item, and a price. So I'm gonna read the data and print the data. So multiple ways of doing it. So I'll do an f open, that's the most important one, and f gets. So f gets the third argument, so it's a buffer. What is n? N minus 1 character, so the number of characters I'm reading. So f gets reads to a buffer 20 characters from the fptr pointer. We can also write to a file. So we have fputs or fprintf. So fprintf print string str to file pointed by fp. So that's the one I'm more familiar with. So we can say f open to write. That's how we open a file we want to write to. So then we have this binary file IO. So if you take the CS50 course, that's the one you're going to use. Writing only characters and strings to a file can become tedious when you have an array or structure, because you don't know the size of it. To write entire blocks of memory to a file, there are the following binary functions. So fwrite. So now we're dealing with bytes instead of like a specific structure. Fread and fclose. For reading, so RB is for reading. RB is the mode for reading. The following programs demonstrating writing and reading from binary files. So I have a pointer to a file, an array of 10 integers, an array of 10 integers called x, int k. So now I'm gonna populate this R array with values from 0 to 9. I'm gonna open a file called datafile.bin with the write mode. I'm gonna write R to write the entire array of size R0 to the file. The first argument is R. The second is the chunk, the size of the chunk I'm writing. So that's equal to like one element of the array. I'm writing R. The total size is size of R, the total size of the array divided by the size of one particular item. So that will give me how many items I need to write, and finally the pointer to the file. And in the end, so I'm basically writing the array to find. In the end, I close the file. And then to read, the mode is RB, and I use fread. So I'm reading to a buffer called x, one element at a time, so that's size of R0, 8 times, 10 times, that's size of R divided by size of R0 from the PTR pointer. And then I close, and then I can print that array. So that's interesting. So I'll say if I wanna write the array, I say fptr to write rwb r size of R0, size of R, size of R0, PTR, and then I close fclose PTR. And then to control the file pointer, I have there are functions for controlling the file pointer. So fseek moves the fp pointer from by num of bytes relative to the position of from pos, which can be one of the following constants: start of the file, current position, or end of the file. So here he's creating a record, first ID, second ID, so he created 3 structs. He writes the records to a file. So size of first, so he writes those 2 records to a file. Okay, and close. So the file contains 2 records, and then he wants to go toward the second. So it's fseek fptr 1.size of item 6 set. So beginning of the file, he reads once, so that will move the pointer ahead once, and then print the second, and then close. So file open, file seek. Okay. This is like really advanced stuff, so if you guys are here, this is like if you're taking CS50, like a hard course on C. So exception handling, if it's something that's going wrong. An exception is a way to avoid, an exception is any situation that causes the program to stop. An exit command immediately stops the execution of a program and sends an exit code. So we can say, for example, exit success, exit failure. If filling the blanks immediately to stop the program with the error code of 4 if the program is num. So exit, how is it called? Exit code. Or we just return. Exit. I think I can just say exit. So if num equals 0, exit 4. Awesome. So now let's see error code. So some functions such as fopen set an error code when they do not execute as expected. In a global variable called no, defining no.h. So we define no, or we include no. And then we can display that failure here. So include no.h. PR and str error. So those things are just good to know. Good to know they exist. So you have st error, p error, that will precede the actual error message. So p error will say error. Okay. So that's fopen and then p error. Edon range. So range is used when it's a range error. So those are all things for you to good to know, but not so useful. So range, no, open, edon, feof. So that's an end of error, of file error. So we open and feof. So if there is an end of file error, something will happen. So here's the quiz finally. So let's go. So we open a file and feof, no, what's the error? So if f open equals no, sorry, fptr. If fptr equals no, we are done. So we create a char buffer. We open my text to read, and this is to read 20 characters into a buffer from fptr. So this is an array of integers. We open a file, a binary file to write. We do f write, and then we f close. Exit the program if the value of num1 is less than, so if num1 less than num2, exit. Fill in the blank to exit the program with the code of 42 if the end of file is reached. So if feof fptr, exit. Okay. Last one, guys. If you're still with me, good job. This was a lot. So preprocessor uses the hash directives to make substitutions in a program source code before compilation. So for example, we've seen hashtag include is replaced by the contents of the stdio.h header files before the program is compiled. So some directives are include, define, and def, if def, if and def. So those are conditional directives. Pragma for a compiler specific thing and an error thing. So which of the following allows to include header files in the source code? Header files include, right? So include the directives. We saw the math, the stdio.h, stdlib for malloc, string, the no, time, and we can also have user-defined header files. So if we created, for example, a .h function with a bunch of functions, we can also include. But instead of the greater or equal sign, we use quotation marks. So include std. The define is used to create object like macros for constants. So we can define, for example, a variable called pi, and then whenever we use the word pi, that's gonna give us the value, or we can define a function. So for area, whenever we call area, that's gonna give us the result. So that's pretty cool. Okay, so we can define a square function that takes an x as an argument and returns x times x. When using preprocessors, hashtag must be the first character on a line, but there can be any amount of white space before the hash and the directive. If a hash directive is lengthy, you can use the / continuation character. So we can define a square like that. So if it's long, we can do something like that. Predefined macro definitions. So there are some macros that are available for C program, like date, time, file, line, stdc. So for example, this one, stdc, we have the date, time. So there are macros for us to use. So the current date is time. Oh no, the current date, not time. The current date is date. If, def, if and def and then def are used with define. So they're kind of conditionals. So for example, our rate is 0.08. If our term okay. So basically it's like a condition. So basically if the rate, what's this? because rate is defined at the top, only the if-def clause will be compiled. Oh, okay, so you can do, so basically if rate is defined, we do 1, 2, 3. Else, we do the second one. So if rate is not defined, we define it, and then we do a and if. So if the rate is defined, we're gonna undefine the rate, printf the redefining rate, and then define a new rate. So it's like conditions for defining things. So fill in the blanks to define the term acro if it is not defined. So if term, and then I need the and if, right? Yes. If term is defined, if it's not defined, and if define term, if and def. If not defined term, define term. Okay. We can have some directives like if level greater than 6, a if level. So we can have, okay. So if we end with an and if fill the blanks to include the printf statement if level, if not level. Wait, how do I do this? If not defined, and if. Okay, this is really rare stuff. Like I've never seen this. Like the if and if and def. The hash operator is called the instrigification and converts a parameter to a string constant. Okay. What's this for? Okay, let's go. So, instrigification. So, toStrX. So it's a toString method. So this turns, oh, okay, so this turns this into a string, a next into a string. So what's gonna be printed? 1, 2, 3, 4, 5. Oops, 5. Hash is called token passing operator because it appends tokens together. Okay, so this is like name num. So here you are adding x to 3. Tokens together. So it's all the elements is a concatenation. $45. No? 9. Okay. So here's a macro that defines triple its argument and use the num of variables as its arguments and output the results. So num. No? Oh, hashtag def. Define. Hashtag define. Define triple. So if the triple macro is defined, so if def triple, define SQR. Otherwise, define triple. And if the preprocessor acts before compilation. What is the output of this code? So my t equals 42. That's a tricky one. So is it 8 or 42? Can I overwrite? I assume it's gonna have an error. Yeah. So what is the output of this code? Square of 4 is 2, 8. So wait. 2, 8. There's no 8 option. So square of 4 is 16. 16 divided by 16, it's 1. I was thinking of square root. So 1. No? Square of 4. 4 times 4, 16. 16 divided by 16, 1. Not 1. 16 divided by 16. Let's see. You guys heard that? That's lightning storm. So why is it 16? That's really interesting. So I'm actually gonna Google this. What is the define def? This is the last problem. Square x equals x times x. Solo learn. Yeah, this one. No. Solo learn. Two, 4. Square. Wait, square is. What is the output? Comments. Let's see. Oh, okay, that makes sense. So you return 4 times 4. Okay, so this returns 4 times 4, not the result. Very interesting. And then 16 times 4 is 4 times 4 is 16. So this is a good comment. That's tricky. It's exactly why one should be careful with the use of macros. It's merely telling the compiler to interpret text differently, to replace a certain identifier with another. So be careful with these macros. This is the takeaway. Awesome. So we finished C, guys. This was hard. Super certificate. I'm now the master of C. Okay. Let's see how this looks like. So do I recommend this? For sure. I think this is a great so by now you guys should see that I'm tired, right? This has been a long journey. But what do I recommend after you finish this? Do the first 5 problem sets from CS50, because this only covers mostly syntax. That's not the gist of programming. The gist of programming is problem solving. So these are the tools that you can use to problem solve. It's very important to know your tools. but only with tools you can't produce anything. You need to have technique, strategy, so you only learn that through practice. So the link to Solo Learn is on the description. Subscribe, give us a thumbs up. I hope you guys enjoyed. Obviously I wasn't able to stay super excited for the entire C course, but this was pretty complete. So I hope you guys enjoy, okay? So we'll have more in the following weeks. See you guys soon.